You talk about like the fact there's a copy of you somewhere in the multiverse, and I just don't believe that. I think like you only exist here. Like this is it. People think that they predict the future, but what they're doing is predicting recurring patterns from the past. The future will not be fully predictable ever. The fact that humans have the recorded history we have now is the only reason that we can even conceive how big the universe actually is. What is the universe actually doing as a physical system? It's building itself. Right, because like there's nothing outside of it to build it. Life is literally the physics of what gets to exist and why. We don't know where the boundary is between life and not life. I think artificial intelligence is life, but it would be a fundamentally different question about whether you want to assess whether it was alive or not.
Sara Walker is a theoretical physicist and astrobiologist who's working on some of science's deepest questions. What life is, where it came from, and whether we'd recognize it elsewhere in the universe, kind of like in artificial intelligence. She has co-developed assembly theory that is meant to distinguish living systems from non-living ones. So we're going to be having a conversation about the non-living systems that we see around us. And she also wrote the book Life as No One Knows It, The Physics of Life's Emergence. She's appeared on Joe Rogan multiple times, Lex Fridman multiple times, and now I'm excited to pit her up against Wes Roth.
Thank you so much for being here. I guess let's kick off our discussion. It's such an interesting conversation. So I guess let's start at kind of the intersection of kind of what I talk about, what you talk about, which is, is AI life? I know it's kind of a broad question, but maybe let's talk about that.
Yeah, I think obviously it's on the tip of people's mind about how intelligent or how alive these technologies that we're making are. And it's a very deep question because we actually don't know what life is. And so I think a lot about fundamentally what life is, coming from the perspective of like trying to study the origin of life and look for examples of alien life, like I've done in my career. It gives you kind of a different lens to think about the question of AI being a life. And I think the easiest place to start with that is really to think about, like there's kind of this fixation that life is going to be defined in terms of fundamental units, and that like a cell is alive, or like we have edge cases like viruses and things like that. But the way that I think about life that is actually, I think, more constructive is more from this like first principles fundamental physics approach, and thinking about the nature of things that require life in order for them to exist at all. And so thinking about the origin of life, there's like a huge number of possible molecules that could be created, but we only see complex molecules in living systems. And what we have seen over the entire history of our planet is the construction of all of these forms, whether they be cellular, multicellular societies, or the technologies that we produce, that seem to be only produced as the product of an evolutionary lineage. And so from that perspective, I think about artificial intelligence certainly as being a signature of life. Like it's something that doesn't emerge in the universe unless you have a long evolutionary history to create something like an artificial intelligence. So this is very counter to sort of traditional conceptions in physics that might say things like Boltzman brains can spontaneously fluctuate into existence, which I don't think is a very helpful way of thinking about things. So from that perspective, I think artificial intelligence is life, but it would be a fundamentally different question about whether you want to assess whether it was alive or not, or like in what ways we should assign agency or those kind of things.
Yes, and I guess, Dylan.
Yeah,
Dylan, thank you for joining us.
I don't know. We could probably cut this part out, but yeah, super excited to meet you. Like, definitely a fan of everything you said, and I can't believe assembly theory explains how we got to here right now. The three of us chatting, and couldn't be more excited for the defying the odds to be here.
So these questions we're talking about are, of course, like very interesting. I think lots of people are kind of discussing it right now because it does seem like AI is getting us to question a lot of things that we thought were kind of obvious. Life and what is thinking, what is consciousness, like all of this stuff. But I guess maybe let's take a step back, because kind of how you're defining life is a little bit different maybe from how people have heard it before. So just so people understand, and there's also a difference between being alive versus not alive.
Right.
And, we've talked to Lee Cronin, so hopefully if people haven't seen that, we have that episode previously that maybe kind of gives an introduction, but maybe let's start there. So what is life, and is why is technology part of life,
Yeah,
I
and
guess.
with that definition, maybe you can point out what's kind of wrong with the NASA definition, because I feel like that's one of
Yeah.
your greatest like gripes to like bones
Yeah.
to pick, you know?
Yeah, totally. Yeah, and I think in order to talk about anything as life, AI or a virus or fire or any other thing that people want to assess in the universe, a atmospheric pattern on an exoplanet, you have to have a rigorous understanding of what you mean when you use the term quote unquote life. And I think this is actually one of the biggest challenges in science, particularly in astrobiology. Dylan, you're pointing out this sort of canonical NASA definition, life is a self-sustaining chemical system capable of Darwinian evolution. Obviously, AI wouldn't satisfy that definition because it's not a chemical system. And there's debate about whether it could be considered self-sustaining or capable of evolution. But that definition actually has a lot of problems even when you apply it just to living things. That people would generally accept as alive. So you can ask whether all life needs to necessarily be chemical. A lot of people think that life is much more about informational patterns or that, like you do want to ask questions about AI and silicon technologies if they're alive, and it's not really the chemistry that we're thinking about as mediating the processes that we would consider living in those substrates. And then there's the issue of like self-sustaining and Darwinian evolution, and there's all kinds of counterexamples to those things. I, for example, as an individual human being, am not self-sustaining. I have to go to the grocery store and, I'm dependent on all kinds of societal infrastructure to support my existence. If you drop me into, the middle of the forest or something, I wouldn't survive very long. I'm not a survivalist. I don't know about you guys.
No, me neither.
But I think most modern humans actually as individuals are not self-sustaining. Societies are self-sustaining. And so, this leads to the question of like, have individuals lost their autonomy? Are they no longer quote unquote alive? And then is like a society as a whole now the living structure, the thing that's actually persisting as a identifiable unit that has a self-sustaining property. So self-sustaining is actually really quite hard because you have to draw the boundaries around the system that is the
Yeah.
self that's doing the sustaining. And so it's, if you go into any definition of life, basically you get into these kind of semantic debates that become very deep rabbit holes about what do these words mean and how do they apply to different systems. And so, the resolution that biologists have taken, at least in introductory biology textbooks, is just to have like a list definition. Life is self-replication, life is metabolism, life requires boundaries and units that are compartmentalization, like a cellular life form. But when we're thinking about the possibilities for alien life, we don't know if any of those things are actually features of all life in the universe or not. And many of those features don't describe every living thing on this planet. And there's, examples that people would find confusing. Like, when I wrote my book, I had like this whole introductory section on defining life. And I really love this example from Carl Sagan that if people use these biology textbook definitions and they came to Earth, they would think cars were the dominant life form because they meet all these criteria. And I think most people are not really satisfied with thinking technological artifacts are life. But as you're pointing out, AI is now challenging that conception because people are interacting with it. They feel like it's an animated thing. And so we want to prescribe these properties of life to it. But again, it goes to like, we don't know where the boundary is between life and not life. So all that's to say, like my approach to the problem and what Lee Cronin that you already mentioned and I have been working on is whether we could start from first principles. And I'm trained in theoretical physics, and I'm interested in whether life is actually a category of nature that the universe recognizes outside of us, right? Like, so there's ways that we as humans describe the world, and then there's the way the world actually is. And science does its best work when we build abstractions that allow us to understand the world outside of our experience. That's sort of the way that Popper described it. And I love this kind of idea of a visual. It's like we have our conscious experience of the world and the way we interact with it. But what we're trying to do in science is actually step outside ourselves and understand the world as it is, not as we perceive it. And when you do that with the phenomena of life, I think basically what we're trying to do is develop whether there are physical principles or laws of nature that actually describe what life is fundamentally. And you have to have some kind of hypothesis or conjecture about what life does uniquely that you would need to build a fundamental physics around. And so this is where the ideas of assembly theory came in, that we were thinking that life is the only mechanism the universe has to generate very deep, complex objects, like deep in terms of the amount of construction history or causal possibility in the object. I can explain what that means in a little bit more detail, but I know you've already spoken to Lee. At scale. And so we conjecture that the abiotic universe can only generate so much stuff. And most of the possibilities you imagine actually can only come about because there is a living architecture that has memory, history, information processing, and through the process of evolution can actually discover, invent new material realities and actually build them and realize them. And AI is one such thing. But because it's part of the human lineage and has all of our cultural history now embedded in this artifact, it looks very alive because there's this 4 billion year history of evolution behind it that was necessary to generate such a structure.
Yeah. That makes sense. So just so I'm clear, and maybe because the way that this really made sense for me is that we kind of draw circles around life based on what we see. It's like, well, humans, okay, that's within the circle. Animals within the circle.
Mm-hmm.
Viruses, who knows? Kind of right
on the edge
somewhere
there.
somewhere. You're saying we're almost able to approach it from a different perspective. Like we can actually assign a number to it, assign an actual metric,
Mm-hmm.
and the kind of, I guess, the assembly index, right? So let's say we go to Mars, right? We take some sort of a mass spectrometer, we find these things, and we find that certain things there are more complex than a certain threshold. You might be able to say, okay, even if we didn't see a single organism, we might be able to look at that and say, we know life was here at some point,
Mm-hmm.
right? Is that okay?
Yeah, that's exactly right. And for many of the cases for astrobiology of interest, we're not going to be able to resolve any individual life form, for hundreds of years potentially. So if you think about exoplanets, like these are planets around other stars, and the closest exoplanets are 4 light years away. So even if we could travel the speed of light, it would take us 4 years to get there. These planets, the only data that we're going to get from them is atmospheric properties, right? So we'll be able to maybe get the atmospheric spectra, and then from that we have to infer the presence of alien life forms on that planet. So there's no ability to say, there's a large language model on this planet or there's a cell on this planet. Like we have to be able to detect the imprint of life in the molecular composition of an exoplanet. And so, from my perspective, obviously, like we have a lot more rich data and rich observational experience here on Earth. But ultimately, the question of what life is comes down to this really fundamental question of like, if I looked at something and I didn't know what it was, how would I recognize it as life? And I think this is a more first principles approach, and why it's relevant to sort of current AI discussions, why astrobiologists have a lot more to say about it, or people thinking fundamentally about life more specifically, and like the kind of approach we're taking with assembly theory, is that you want a theory that you can validate in a diverse set of materials across diverse kinds of living systems and non-living systems, and actually be able to say, I can measure the amount of life in this system. And this system is, like assembly theoretically, we would say this system is disassembled. And it's both assembly index and copy number that gives you this kind of, I think about it as a depth into possibility space. So if you imagine that at any point in time, there's a certain number of possibilities that can be created. So if you think about all possible technologies or all possible molecules or all possible Lego structures, only a certain number of them you can actually build at any given time. And that constrains what you can make in the future. And so assembly theory is basically talking about this possibility space as a physical space, and that life is moving through the space of possibilities, selecting structures and making potentially more complex ones. And this allows us a way to detect when life has emerged in any material, not just in chemistry.
Hmm. Okay, so I'm not sure if you caught this. This is only a few days old, but there was a company called Eon Systems that just recently has finished putting an entire fruit fly connectome into
Perfect. Yep.
a physics simulation. So we have
Yeah.
we have a fruit fly. Every neuron that was in the biological version, which went through actual evolution and actually had a chemistry background, has now been sort of digitally copied. It's moving around in a physics environment where it thinks it's a fly. It's looking for food. I don't know if it feels hungry or not, if the nervous system gives it those signals, but either way, they would be all digital. Maybe you could kind of tell us, like, does that kind of swapping just work with assembly theory, or what kind
No,
of
no,
things are
absolutely
coming
not.
out
I
of you?
mean, I actually even had an allergic reaction when you said it thinks it's a fly. I was like, well,
Okay, yeah, maybe
actually,
not. Yeah, the neurons.
your mental model thinks it's a fly, but whether the model thinks it's a fly is another question entirely. And we are so bad at actually embedding our understanding of the world in other cognitive agents, even just with animal behavior. Um, so I think but there's also another example, which was also in the literature this week, where there was a simulation of like a whole cell. And like there's a simulated cell undergoing division. And so I think you're going to see more and more of this because people are so excited about the computational power we have now that there's some conception that we're taking physical reality and we're transporting it into the computer. But I think that's a completely a false kind of statement. And I don't know the best analogies to describe how I think about this just yet, but it's like we observe the world, and because you can replicate your observations in another system doesn't make that system the same thing as what the original thing was. And so I can give an example actually with fireflies because I was just talking about this yesterday. But my lab had a paper out on like a firefly model for SETI, which was supposed to, like we were basically using fireflies as a non-human communicating system to model the possibility space of alien intelligence, because every single model that's ever been put forward for aliens and how they might communicate over interstellar distances has been based on humans and our technology. And we obviously don't know what aliens are like, but at least having a non-human model allows us to expand the thought space that we're working in. And so we used a firefly, like it was actually a model developed by Firefly Communication, and put it against a pulsar background. So pulsars are flashing, in out in the universe, and they have very regular patterns, just like fireflies. And then you could show that something that was evolutionary adapted against that background to like distinguish its signal, like a firefly would try to be against other fireflies in the same community, would actually be a distinguishable pattern. Now, the reason I'm bringing that up in this context is. It got me down this deep dive trying to learn about how fireflies perceive their own signaling. And, we have this very regular pulse pattern that we see, but actually, like, we don't understand how the fireflies interpret that signal. So, like, the state of the art is actually to try to get in the firefly brain and understand its own conscious perception of the world and what actually sensory input is it getting, and how is it responding to its environment based on like the mental model that it's building of the environment. And, like to try to do that for all these diverse organisms is actually super hard. So I see a lot of work where people model a system, but they model it from the human labeling the data. They don't model it from the intrinsic perspective of the organism or entity that they're trying to study. And I think this is a really, really hard conceptual leap. So, and it gets into issues of consciousness and things I know you guys talk about, but, it's one thing to model pattern behavior. It's another to say that behavior has the same experience of the world as, um, as another entity displaying the same behavior. And you even know this comparing two humans. It's like two people can act exactly the same and have totally different feelings about it, right? So it's like it's not a non-obvious feature of reality. So I don't know why people are ascribing so much behavior to simulation, or so much human agency, human cognition, consciousness to algorithms, except for the fact that it's the first time in human history that we've seen these particular things represented in an external environment and not just in our minds, right? But it doesn't mean that they are our minds. And most of human history has actually been about the externalization of our thought processes in our physical environment. Early examples are even like when we first built physical structures, and we could like actually human culture started because we built structures in our environment, and they persisted long enough that like the next time the human migration pattern went there, they started to have a memory that there were people there, and they could build up a culture over time because they had things that were longer duration than just a parent teaching a child. Right. And then when we get written language, we have even longer generational timescales. So these technologies that we're building, whether it's like physical buildings in our environment, written text, or a machine learning algorithm, or a simulation of a fruit fly, are just acquiring more and more knowledge that we've built into um, our own minds and our environment, and allowing us to see those in higher resolution and actually externalizing, like these models we have so we can understand them better. So I think the interesting thing for me about the fly is that it raises those kind of questions, like how would you know that this thing actually thought it was a fly, or and if you can ask better rigorous questions, then that gets more interesting.
Yeah, I know sometimes I feel like I'm less conscious in the morning than I am until after my coffee, and throughout time it's kind of changed. So I
I'm such
definitely
a caffeine addict, I get that.
yeah. But if we do, so I was thinking maybe we could like a little thought experiment though. But if we keep kind of moving down the route where the fruit fly gets more and more kind of one-to-one simulation, just obviously just simulation, it's not alive or anything, but it does have more and more of a nervous system. That landscape that it's in feels closer and closer to our reality, and maybe millions of years of evolution can take place digitally in a much quicker time frame, where you add multiple fruit flies and they mate, and over time, like all sorts of interesting things start to happen. Do you feel like consciousness and kind of higher level like ordered assembly could start to take place, and then we could maybe learn about consciousness or kind of the things that we are?
um I I am not convinced that deeper simulations are actually going to get us to a deeper understanding of reality. So I think the challenge for me is, the universe has clearly constructed very complex structures. So, like if I wanted to, like simpler than a fruit fly, I just want to simulate chemistry, right? Like obviously, like a fruit fly is made out of chemistry. And I like these chemistry examples because they're a little bit more concrete, but I think these kind of arguments poured over directly to the question that you're asking. But if you think about, all possible molecules that are fairly small, like a amino acid size, like very small molecular building block used in life. And you want to say, I want to simulate the space of all of these molecules. There's not actually enough resources in the entire universe to build all those physical possibilities. And we run up against like computational limitations all the time that like why are we having to build these massive data centers and computational things is because actually it takes physical resource to do simulations. And it's really interesting that the universe has actually generated structures that it can't simulate. And I don't really know what to do with this feature, but like the universe is like, if you think about the fact that the universe has like a finite amount of material in it, that material is the physical foundation of what can be used to build a computer and to do simulations. So you have a finite amount of time, a finite amount of material. That finite amount of time and material actually is insufficient to simulate itself. Um, and so I think that we will hit with any system hard physical boundaries, which the system actually can't describe itself. And this comes from the foundations of mathematics. Also, if you look at like Gödel's theorem and the foundations of computation, they were actually like computability as a theory was built on this idea that there are things that are not computable. And we want to talk about computable things, not computable things. And then even in the space of computable things, there are systems that, like try to talk about themselves and can't, and lead to all these sort of like mathematical and computational paradoxes. And so it's kind of weird to me that out of a tradition that started from deep principles of unknowability, this was what like Alan Turing was dealing with like the halting problem, things like this, has emerged 100 years later, this like hubris that we're going to be able to simulate all of reality on a computer and think that that's actually like a physically realistic possibility. And so I just I don't see that being the ultimate path to understanding things. It's like if you make the map too precise to the territory, you haven't actually gained any understanding. You just have the territory duplicated. It's like it's not what we do in science. Like actually, science we build more foundational understanding, and in some sense, we build simplified representations that are deeper principles and more abstract because they actually allow us to understand the system better than if we could just fully replicate it. So I think there's some kind of like cognitive mismatch between what we're doing when it's almost like it's an easy way out for us to say we can simulate these systems and therefore we understand them. Um, I don't find it satisfactory on any level.
Yeah. Yeah, that makes sense. One very interesting sort of concept that popped up, a way of thinking about what this universe what this universe is kind of think of it as a creativity engine, right?
Hmm.
So if it's generating novelty, life, and part of life is us creating technology, etc. So I mean, it makes sense why, like for example, a coffee mug. We're all coffee lovers, I'm sure. That you can we see that shape in some form replicated across the Earth. There, oh, there's I see one now, actually, right there. I don't have one. I have
Flying
one near.
by coffee
I
mugs.
can't reach mine, but it's like just off screen here. Why? It's useful, right? And so we replicated. We found, oh, this shape really does something. And I guess something similar, maybe, and correct me if I'm wrong on any of this, but something similar is happening with life, it seems like, right? There's something that's quote unquote useful that gets developed and it sticks around because it becomes part of the
Hmm.
DNA and it multiplies, and DNA, therefore, is like one of the more stable molecules or whatever, just because it keeps multiplying if it's useful. And so it almost seems like the whole point is just to build more novelty, more useful things, more complex things. So I don't know. I don't even know if I have a question, but is that what this whole thing is about? Is just this creativity engine to create complex stuff?
Yeah, I mean, this gets more into sort of philosophical questions about the nature of life and also like, does the universe have a purpose? And it's interesting because like very early days of like trying to build theories to actually um understand fundamentally what life is and then to be able to look for life. I started to think about life as the mechanism the universe has for bringing new things into existence. So, like, life is literally the physics of what gets to exist and why. And so I think, like my conception of the way the mechanism, the fundamental physics of the way our universe works is very different than standard physics, and it comes from studying fundamentally the nature of life. And so standard physics would tell you that the universe started from initial condition, and we have fixed laws that exist outside the universe, and they evolve the universe for all time. And from that perspective, it's easy to think you can sit outside the universe and simulate it because you just have a mathematical equation. You just need the information, the initial condition, and the whole thing can be simulated. And that's not my conception of the universe because it assumes that you have an observer that exists outside the universe that can describe it. And for me, the universe is everything. And in fact, the universe is not like a static block structure. It's the emergent property that like a mind inside the universe would talk about is all of the creation that it sees around it. But what is the universe actually doing as a physical system? It's building itself, right? Because like there's nothing outside of it to build it. So I have a sort of sense of the universe as a self-constructing system, and that's why I think this idea of possibility needs to be really considered in fundamental physics very seriously, because what the universe is doing is exploring what's possible and generating physical structures that can persist in time, which allows more things to be possible. And that fundamentally is what life is doing, but I also just think it's a more general foundation for what physical reality is. And this gets into reasons why the universe can't be simulated, because it's like you can't build something outside the universe to simulate the entire universe. And it's not like within the knowable territory to be able to
Mhm.
do something like that. And it's actually not the mechanism of how the universe generates novelty. So like when you're doing things like simulating the fruit fly, you're basically encoding the past observations of all the behaviors of the fruit fly in the current moment, and you're building a memory. So like we talked about, part of this whole assembly theoretic perspective is that the universe is acquiring deeper and deeper memory to construct more novelty. So I see the machine learning algorithms as being a very deep kind of memory for a technological intelligence to have. But I don't see them as a mechanism for generating novelty on their own, or like actually leading to sort of the further scaffolding of the creativity of what our system is doing with humans, definitely. But like on their own, I like it's hard to know, or on its own. I don't like we anthropomorphize even the way we talk about these technologies are really riot.
Yeah, it's very different. Yeah, there's
Yeah.
certain words that just kind of like the observer or a person or intelligence or consciousness is baked in somehow. We have to
Well, they
kind
were
of like,
sold to us that way, right? So it's like as soon as, like as soon as ChatGPT comes
They have
online,
names.
Well,
Yeah.
yeah, exactly. And Claude, right? I love Claude. Claude's my favorite, but but I think like it was like in the sort of early marketing of these technologies, they were phrased in a certain way that was very anthropomorphizing, and so people have adopted that like even the way that they're trained to talk to humans, it's very much to be user friendly and to give the perception that they're like us, even though it's literally an it. It's a very deep it that records a lot of information and can, predict stuff within the space of that information. But I think it's really hard to think cognitively clearly when human language, because it's not set up for this new technological phase that we're in, actually, like we don't have languages to talk about the things that we're interacting with. And so we're getting confused by using words in wrong context. And people do this all the time. Like I basically think like the word agency has been completely reinvented in the last year or two, right? But we carry over the concept of the old meaning of the word to the new meaning of the word, and that's when people get very intellectually muddled and we lack conceptual clarity.
Yeah,
And
especially when there might even be like intentions behind that to help things
Yeah,
sell and stuff,
totally.
and you're like, oh,
Yeah.
don't hijack that word. But sorry, go ahead, Wes.
Yeah,
I
no, I
want
was so angry. Well, the first time I saw like your personal AI agent on a poster in an airport, I was like so agitated. I was like, you can't take our words.
I definitely
But
want to
yeah.
come back to agency, and because I know consciousness is also kind of similar to that. I just want to just one quick thing based on what you were just saying that I'm kind of just popped into my head. So one thing that I was very very curious with the development of AI that I've noticed is in all the science fiction books and all the stuff before, we tended to describe AI, what we thought how we would develop it, as this highly engineered structure with
Hmm.
similar to a Formula One car. Now it really appears like we're not really engineering it, we're growing it, we're creating the
Hmm.
environment. So it's some part, it's like some emergent part of physics or the universe. And that seems to me very similar to what you're talking about, how
Hmm.
at the base level, or what some fundamental property of the universe is just to these things emerge that create complexity. And this seems like a new idea. So maybe is
Yeah,
science,
so I
yeah.
think I think that's actually a very deep point that you're hitting on. And so like with assembly theory and the way we talk about the assembly index, it's like assembly index is supposed to be an intrinsic property of the object, right? So some things are very causally deep structures, like the three of us are. But the point of doing that, making it a feature of the object, means that we can do physics and we can do measurement on the object, and it becomes an objective feature of the object. So that's a really important scientific point. But what that becomes evidence of is that there's something in the environment that can make that thing exist, because the thing can't build itself. And so all of this complex structure is actually evidence of complexity in the environment in some sense. And this is part of what I'm saying about the universe being self-constructing, is like I can't there the idea in physics I mentioned earlier about this idea of Boltzman brains, like this is a very standard idea, very consistent with current theories in fundamental physics, that a brain can spontaneously fluctuate into existence at any moment in space and time. And this becomes paradoxical in physics, because the idea is that if the brain can fluctuate into existence, there's no way of you knowing that you're not such a brain, because your experiences would be exactly the same. You just fluctuate into existence, and for the flash of this second, like you're having all the experience and memory that you would have had, and then you flash out of existence, but you wouldn't be there to know that. So it's sort of paradoxical, like, because you wouldn't know the difference observationally if you're a Boltzmann brain or not. I think it's just a ridiculous assertion, because there's no evidence in our observational environment that brains form this way. And we do have persistent structures, but more importantly, I think physically, brains emerge in bodies on planets, along with populations of other organisms that are evolving in the same way. So I don't think this idea of a isolated brain is at all sensical. And part of my reason for pointing that out is it requires this very deep construction history of like, systems that can make cells, and the cells are reproducing, and the cell, like, and then the multicellularity gets selected, and even like features of the human brain are so socially constructed. It's like one of the reasons we have a hard time seeing reality for as it is because our brains in early development pick up on social patterns and social cues, because the thing that's necessary for human baby survival is to be socially adept and actually be cute for its parents and get that, like, and be able to pay attention to human signals and not the environment. So humans are actually really pretty bad at seeing reality because of the way that our social brain developed. And I think some of the artificial intelligence technologies are tapping into that sociality aspect. And usually, like, why I like people that are kind of on the spectrum or like autistic, and I think they like tend to be better scientists, is because they don't have the social cues so much, and their cognitive architecture is actually a little bit closer to physical reality. I think, Lee, not he's not necessarily on the spectrum, but he's like a great example of this, where like the way that his cognition works, I think, doesn't pick up on the social human cues as much, and he's very good at actually like understanding the physical world outside of these artificial architectures that we build through human language and social cognition that are very useful for our functioning in a social system, but don't really tell us how reality works. So that was a bit of a tangent, but your point was very deep. So
Thank you.
there's lots of related things.
Yeah, that's interesting
Yeah.
because I can see kind of that connection between like how you view the Boltzman brain and then this idea of like the fruit fly brain and those things, and how you'd
Yeah.
be like, oh, okay, it's not the same. And now we got a good soundbite for Lee Cronin too. Like, so we got everything we need. But I was,
Yeah, I hope he's okay. I said that. I
he's
see
like,
someone like
he misses some social cues, but it pays off in other ways. Like, it's no big deal, you know? I
we're
think
good
we,
friends, so I think he'll be okay with it. But it's one of the reasons that I respect him so much, because I think he's just his own person, and like you can really value people like that.
yeah,
Um,
I absolutely take it as a compliment. It's
yeah,
somebody actually who has their own kind of thing in the world and sort of knows who
yeah,
they are
totally.
and everything. So I was gonna maybe talk about you have one of the more interesting takes I've always thought on AI replacing us. So it comes up all the time, like
Mhm.
on our audience, like, are people not gonna have jobs? Are they not gonna have purpose? Like, AI is gonna replace us. And I've heard you actually describe it before as more like a category error. It's almost like you're
Mhm.
not stepping back big enough, because you said it's like cells fearing multicellular
Yeah,
organisms. Like,
yeah,
maybe you could just explain maybe a different way to think about the disruption AI might bring
sure.
to humanity.
I mean, I think so on the shorter time scale, like just human cultural evolution in the last few hundred years, like anytime we invent a new technology, there's always a job displacement, but it doesn't end up being a net bad for humanity, because like it opens up new niches and new kinds of things that we didn't even know we could do. So I think one thing is like, because our lifespan is really short, and we get kind of accustomed to the world functioning a certain way, it can feel radical within our lifespan that things change so much, and oh my God, jobs aren't what they were 10 years ago, or they weren't what they were, uh, you know, um, 20 years ago. But it's kind of crazy when you start to think about the fact that the entire human population turns over about every 100 years. So no one alive today was alive 100 years ago, and nobody alive at that point was alive 100 years before that. And so you have this entire turnover of the world population on a typical time scale of 100 years. So like we don't really have that longevity of experience to really realize that these kind of radical shifts are maybe more normal on the time on the trajectory of human evolution, which I think is kind of an accelerated example of evolution, or on the template of like the biosphere as a whole over billions of years. So obviously there are major evolutionary transitions that have happened in the past history of our planet that were maybe quite bad for some of the species alive at that time, but not universally bad for the evolution of our biosphere as a whole. And so one example is when you evolve multicellular organisms from unicellular organisms, there's a lot of trade-offs there, right? Like a unicellular, like a single cell now no longer has any autonomy, and in fact, the multicellular body plan is such that almost all of the cells in your body can no longer reproduce. Right. But our species reproduces because we have a germline, and those cells can reproduce. And so there's all these kind of like new cooperative layers that emerge at different scales. And obviously, I'm very happy that I'm the entity I am. Although I do find it really shocking that every single organism on the planet still goes through a single cell. Like every single multicellular organism on the planet at one stage in its life cycle is a single cell, which is like totally radical that we have to go that far in history, evolutionary history, to actually produce structures like us. Um, but so if you so I guess where I'm going with this is I tend to think about life on the many billion years time scale. And so where we are in this sort of like current 100-year moment that everyone alive that's a human that you can talk with is experiencing is a very, very, very tiny slice of that. And if you try to think about the bigger picture of like what is happening with life writ large over billions of years, and like what is the purpose of life and the progression of life. Like purpose is a hard word to use in science, but I'm just using it because I think that's sort of how intrinsically how we feel about these questions, just as humans. Um, it seems to be the case that our planet is the most creative planet in the universe that we know of in terms of like the structures it's generated over time, the novelty that's become apparent, and the kind of possibilities that open up. And so for me, I don't see, it's hard because obviously a lot in our environment is changing. People are losing jobs or people are having existential crises because they're, able to talk to a chatbot. But in the grand arc of like, what's coming next, these technologies are enabling a lot. And presumably they're actually going to make human lives a lot better if we look at the sort of trajectory of what technology has done in the past for humans. Um, and and it's going to change the landscape of how we interact with each other and also how we interact with our technology, but it's not fundamentally different than I think things that have happened in the past. And I'm really confused when people think this is just some major level shift and like nothing like this has ever happened in the history of the universe or the history of the human species or the history of our planet. Like suddenly there's an artificial intelligence that just popped out of nowhere and it's going to change everything and like doomsday is going to happen. And, that narrative is not new. Like people saying that kind of thing is not new because when new technologies have emerged in the past, people have traditionally been scared of them. They have had, dreads of existential threats. My favorite one when LLMs, started becoming very popular that I didn't even know about was like, in ancient Greece, they were like afraid of having people read because and write because they didn't want the dead talking to them. So I think, in photographs, like when photographs were first, becoming, a prevalent technology, people were afraid they actually took your soul. And that was what was recorded in the image. Like they were, like soul stealing devices. I think this idea that our technologies, like what we do when we externalize our mind and the environment, and now we can do all these new things with our environment that used to be internal cognitive processes or things that were only related on human communication, like stories were always oral, and now we have written stories so we can read people 2,000 years ago without having to go through every voice in between. Like these kind of things, they're traumatizing. They're existentially traumatizing, but they are part of the human story, and humans are uniquely poised to develop such technologies, and they end up leading to all kinds of brilliant things that our species could do that we couldn't do before. So I'm a glass half full kind of person, I guess. Um, but I'm not. I don't feel threatened by AI intellectually. Like a lot of people that think they're going to replace, like the stuff about them replacing physicists, I find so ridiculous. It's like it's like the new, like I don't know. You guys see this stuff in the news? It's like, oh yeah, they can do string theory, and they just did this theorem proving thing, and they're going to replace all like physicists is the smartest job, and they're going to replace all physicists. Therefore, all intellectual work is done. It's like kind of one of these narratives that I find it insane. I'm like, well, clearly they don't know what physicists actually do. Um, so I don't know. I think humans are an incredibly adaptive species, an incredibly brilliant kind of physical configuration for a system to have. I'm very grateful I exist, but I don't limit the potential that we have or how we integrate with the rest of what the planet is doing, and the fact that we live on an incredibly alive planet, and it's getting more alive all the time. The more creative we are, and the more things that we actually build. Um, so it's not the way other people think about it, but I have reasons.
Okay, so we still don't understand how distributed brain activity kind of creates a unified conscious
Hmm.
experience. Um, if we can crack that in biology, like what do you think it might tell us about AI and if AI could ever have the same thing?
Well, I think it would answer that question, right? So, but I almost wonder if the way that we're approaching it is not from the right perspective, right? So, a lot of um, a lot of the work on trying to understand consciousness is like basically picking apart the human brain and looking for like the neural correlates of like what we call conscious experience. And the best way to understand if something's conscious is verbal report out even now, which is one of the reasons that LLMs are even part of the discussion, right? Because if if an entity in the past, before all of the stuff that's happened in the last few years, if something could state it was conscious, that was like the best signature we had
Yeah.
of whether it was conscious or not. But that was never a good scientific criteria. It was just this is what we can do to start to approach this question and maybe build better questions from it. And so I think this is something that is really hard to understand about the process of science, is that we get stuck in paradigms for a really long time where like we are banging our head against a wall asking the same questions, and we have a really hard time trying to formulate the best way of asking them. And consciousness has been this way for decades, just like the problems of alien life have been this way for decades. So I draw a lot of analogies between the sort of hard problems of consciousness and the hard problems of life, and what people in the neuroscience field have been dealing with trying to formulate consciousness, and what astrobiologists have been trying to do with life detection and formulating life. Like if you forget about the questions and you just look at like the kinds of approaches and the way that people have to ask questions when they don't have good conceptual foundations or theory to guide them, it's almost identical. And it's usually by recognizing that there's a phenomena you want to explain, whether it's consciousness or life, and then finding a correlate for that phenomena, whether it's a pattern of neural activity or a DNA molecule that like so far we only find in biology on Earth. And then you go use that basically as a proxy for the phenomena. And so I would say, and so the way that you're posing the question, Dylan, is like, well, if we understood the patterns of the neural activity in the brain, we would understand consciousness, and then we would be able to understand if an LLM was doing that. But basically, what you're doing is you're pattern matching from this physical system, some way that you've labeled the data, and you're calling that consciousness, and you're moving it over and saying, like, does this match that data? And in biosignature science, we do the same thing, where it's like, well, Earth has these sort of atmospheric gases. If I find them on another exoplanet, I'll have detected life because the pattern matches.
But I
But
might not be am I not abstracting enough or generalizing
yeah,
enough?
no, that's exactly my point. So I think the way that I would approach those kind of questions is you actually have to have a conjecture or a hypothesis about the phenomena you're studying, and you can't use the phenomena to explain the phenomena. So you can't take consciousness as fundamental and then ask questions about consciousness. You have to say, what are the properties of the physical universe that allow me to talk about a thing like consciousness existing? And so this is the way that I've approached the question of life, is like, I can't assume life to explain life. I have to say, well, if I forgot about my human categories of nature and I was really just trying to say there's a regularity of the physical world, I want to describe a particular pattern in the physical world, what would be my first principles approach to describing the things I associate with that set of phenomena? And then can I build theories that allow me to test that against the cases that I think are actually relevant? And this is a really hard process to do because you have to do it iteratively. So like when I was first starting thinking about life, I had like a bucket list of like 10, things that I think are really relevant to what life is about. And they would be things like, um, information plays a causal role, or you have to have dynamical systems where the states and laws are not separate. So I talked about already like an initial condition of the universe and a fixed law, but like those are human categories. Like somehow they collapse when we're talking about living systems because they're open ended and the rules are changing all the time as a function of the kind of systems that emerge. So like there was this whole list of things, and basically what it is just a conceptual map. But you don't want to hold on to any one of those definitions, because the whole role of a scientist is to assume we don't know what we're talking about. And we want to build a theory that we can test against reality. And what I see too much is people putting too many assumptions in and then looking for the phenomena as they predefined it, rather than letting nature tell them what the phenomena is. And we are so in this place with consciousness. It is like, and consciousness is like, is obviously much harder because it is our experience of the world. But everyone's very fixated on explaining experience rather than explaining what would be the consequences of whether an entity had experience or not. What does that even mean? And so for me, I have like, my own developing theory of consciousness, which is just basically about like causal depth and possibility space, very related to assembly index. But there are sort of testable consequences of that eventually we'll be able to work out with like all the other stuff we're working on. It's too long a bucket list. Um, but I think even Dan Dennett wrote this. He's like, you don't want to ask the hard problem of consciousness. You want to ask the hard question of consciousness. Is like, what is it empirically tractable? Like, what would be the consequence if consciousness is a real physical thing? And right now, a lot of people think consciousness does not impact physical reality. Somehow it's like internal to reality because that's the way that we experience it. But I just don't think that's the right framing. I think it's got so many problems with the ontology of the way that we talk about this problem. Um,
Yeah, this is so interesting, so deep, and this really helps me get my mind around it a little bit, hopefully, because we've seen, as we're talking more about AI, I'm really thinking no one knows what consciousness is, and we have such different ideas of what it is. I really like how you're saying, so like, what is the proxy for it? So we can't measure somebody's subjective experience, but is there a proxy? Like, what does it mean? Can we
well,
measure?
actually, yeah. So that's kind of what I'm saying, but I'm even saying I'm not sure that that's the right question to ask.
Okay.
Like that became the hard problem of consciousness because that's the part that everybody thought they couldn't explain with science. But I think you don't you want to ask questions about like imagine that you were just observing the world and you wanted to pick out what were the conscious entities in the world, right? Like that's actually the science, because as scientists we have to do science from the outside the system, but obviously we're inside the system, which is one of the reasons that I think life and consciousness are hard, because you can't take fully that external view. You need but what we've done so far is like physics is built on this, for example, this idea that you can observe the universe from the outside and describe the laws. And actually almost all of science is built that way. And it's necessarily built that way because of the historical development of these fields. But when you get to consciousness, you're like, well, I am the system, or when I'm life, I am the system. Um, and I think it's still possible to do what we do in science and objectively study those systems as if you're from the outside. But you need theories that account for the fact that your entities are in the systems that are being described. And so one of the hardest things about what we're doing with assembly theory that I think, we haven't communicated very well, but I think very deeply about, is it's basically a theory of physics that it's possible to describe the universe from the inside. Like there's no external law in the theory. Like they're all internal to this objects that are being described. And so I think the fundamental issue is often in science we don't ask questions the right way because we have paradigms that don't work for these problems. So the question is, what paradigm would work for this problem? But that means that really fundamentally it's not a question of the answers being wrong for the questions. It's like your questions are wrong. And so I think consciousness is in that space. So I don't even know how to articulate exactly what I think about it because like the language we have is so limited, and it's stuck in these ways that we have of thinking about things now. And really all I'm saying is like there is a way that we talk about things right now, but we need to get to some other space entirely to ask questions about the nature of this particular phenomena because these ways are not working. And I don't think that doing things at scale, having better computational power is going to fix this problem. I don't see that happening. And I don't see happening that, I think what we'll do by this, neural mapping to algorithms is we'll build better algorithms, but we won't have any deeper insights into the nature of consciousness.
This will be a kind of quick answer if it doesn't work, but what do you think about the word intention? Does it bother you, like it has too much assumption around it, or do you kind of feel like when the universe is sort of moving towards like higher assembly objects that is an intention?
First off, I should give the caveat that all words bother me.
Okay.
I
What
have a
I
little bit of that as well. Yeah, I know what you mean.
They're like just words are so radically imprecise to the concepts that we're aiming to communicate, and I think people think words carry much more meaning than they do. So oftentimes when I communicate with people, I don't look at a specific word. I look at like sort of the pattern of what they're communicating, to try to actually understand the meaning that's being conveyed.
Does
And I
that
think a
annoy
lot.
people when you do that? Because I annoy people when I do that. I'm just wondering,
Yeah.
do you get that same reaction or no?
I think probably.
Yeah. Okay.
I think it's also quite hard for people like it's like people will be like, "What do you mean words don't have
Yeah, it's
meaning?"
usually that
Right.
they haven't thought that
Right.
deep about it. They're like, I don't know, I've just been using that word.
Yeah.
Like, I'm not really sure what I mean. Maybe in this
Yeah.
context or that one.
This is another, like, I mean, why do LLMs work so well is like the sort of structure that we have for language is a set of associations that humans use as pointers to objects in the
Yep.
physical world.
Yep.
And you build a common semantic representation in your mind by communicating with someone that understands that pattern. And like what happens with kids, you have to physically point to the object so they understand the meaning. But humans get into these abstract spaces with our words where there is no longer a physical object for us to point to. So the more abstract our language becomes, the harder it is actually to say that two individual humans actually have a shared representation of what that concept is. Um, but with the word intention, I have no problem with like teleological language, which intention is, like goal directed language or purposeful language. Um, as a scientific language, I think I just want to put the caveat that like these are properties that emerge in the universe. They're not imposed on physics or the way systems behave by some external designer or intelligent agent that's observing the universe and set the laws of physics in motion, for example. Like these are properties that um, actually emerge along lineages through the process of evolution. So when you say something has intention, all that suggests to me is there's a history of evolution and selection that put intention into that system so that it can repeat sort of, at least not if specific past patterns, um problem representations of past patterns. So this is like, like why are we good at generalizing to new things even if we haven't seen them in our past? It's because we have some abstract representation of the problem space that's been presented to us in our past that we can apply to the future. um so intention to me is actually a signature of the past, and past selection. And I think this is also something that's quite hard because there's a lot of language that we use that's future directed. Like this thing predicts, this thing has intention, this thing has goals. And what we don't realize is those are statements actually of the history of that object, because that physical structure you're talking about was evolved and selected to have those properties. And the prediction is about the past being recorded and being able to be repeatable. It's not actually a statement of the future because the future hasn't happened yet. This is another sort of radicalism of assembly theory. But I'm a strict presentist, which is philosophically and scientifically. But like as a person, it's really hard for me to like cope with this. But I totally agree with it as like a scientific platform. But the idea that only the present exists. But I think the present is thick in the sense that like we have these causally deep objects that have a lot of stored memory in them. So a lot of the past exists in the present moment as a deep causal structure, but the future hasn't been created yet. So it has no existence until it gets generated. And people think that they predict the future, but what they're doing is predicting recurring patterns from the past. Um so
So
yeah.
cool. So
Yeah.
cool. Sometimes I love your answers. That's great.
There's so many
Yeah, it's so true
different
though.
areas that I want to go into. There's so much there because it's Ilya Sutskever was recently saying that that's kind of like one thing that's missing from large language models is this idea of intention, and he compared it to like human states or human emotions. He said maybe they need emotions, like how sometimes you just move in a
Mhm,
certain direction, like people who had, I don't know, poor childhood, they want to get richer, and it's not that they have some goal, it's just
mhm.
they have this, I want to get to this state, or they think in the future they'll get to that state, so they work in this direction. um and also the fact that like, you're saying how we have certain words that are grounded in meaning, like this is an apple, this is a rock, and then more and more layers of meaning that at some point is just disconnected from these little pointers. The other thing that kind of was so interesting for me to realize is LMs have no actual connection to any base reality there. They're all just words related to one another because they've never, seen an apple. It's just how apple relates to all the other words. Um, Can
Yeah,
we?
you know what's really
Mm,
interesting? Because like there was that famous example of like the Golden Gate Bridge, where like the LLMs started to build the association of it, like and have like a representation of it, and so people started to think like, oh yeah, we're recognizing the neuron, where the Golden Gate like bridges in the system. But all of these things, so there is an interpretation, right? Like these systems actually have a representation. But again, I don't know if the hardware in the computer of like the electrons moving around silicon chips has any awareness of the Golden Gate Bridge. But I think a human interacting with that system would be able to say, this is the Golden Gate Bridge. And that's sort of the level of the dichotomy of the question. And so when I see these systems, I don't think about how deep that neural network is in the computer. I think about how deep the human mind is. That our cognitive architecture is so freaking deep in terms of like the abstractions and the connections we build, that we can build an algorithm that imprints this huge pattern that human culture has built, which is human language, and encodes it into a tiny box. Like these are like language before LLMs, is massively distributed. And then we have, over all human minds and all books. And now you have this dynamical registry where you can just access human language and get like these report outs of it. And that architecture is so deep that like we can see these things in it, but it's actually like you're looking in your own mind and like the patterns in your own mind just now physically stored in a device in your environment. And I think that's more wild to me. And I wish more people were talking about that. Like, I just think what humans are and what we create is like so causally powerful that like we are completely underestimating the architecture of our own minds as these like amazing explanatory machines that are capable of building these abstractions. Um,
Yeah, if you're since you're like kind of building a theory about what life is, but you're also alive and doing
yes.
it, does the work ever get like kind of surreal? Like you're trying to
Oh,
explain
it's
the
so
very thing
meta.
that
It's
you're
so meta.
doing and
Yeah.
explaining?
It's actually kind of funny. I was telling my lab, because I have like grad students and postdocs I work with, and they're absolutely fabulous. But I was trying to explain to them that I'm a method scientist. Like there's method actors, and they like they stay in character, so they like really understand, like the character. Like I have a hard time shutting off what I do for work versus what I am as a person, because and it actually maybe it just comes with the process of being creative, because like a lot of artists have to really embody themselves in their work, and I tend to think of like what I do professionally much more as a creative exercise than I do as like the way people would traditionally describe a scientist. So I have this very embodied experience about what I think the physics is of what life is and how I'm trying to describe it. And I do have a very hard time shutting it off. So it's like if I'm hanging out with my kids and stuff, it's like that's probably like the only time that I'm like, all right, yeah. But it's ever present. And I'm constantly trying to regularize every observation I have almost into like formalizing these ideas and trying to test them rigorously. And I sometimes also joke that the only reason I'm sane is because I'm a scientist, because I actually have to physically force myself to test things. I think I can't go into these like, crazy loops of like building my own reality for myself, because it has to be actually something that works in the real world. Um, but it is, I don't know. I also find that part kind of fun. But yeah. Uh,
And to that point, that's very interesting. So, I mean, if we're looking kind of like the assembly theory, how you're viewing the world, I mean, is there anything, number one, that's like really surprising to people from that perspective? They would find very surprising. Is there anything that we can use that to maybe predict the future a little bit? Anything that kind of emerges out of that that is fascinating to you?
Well, I mean, I think actually it's interesting because it's a scientific theory, but I think some of the most interesting ideas for me are like the new philosophies that emerge out of the
Hmm.
theory.
Hmm.
And one of the philosophical, but it's also, I think, an empirical concept is the idea that time is a material property. And what I mean by that is actually this idea of the assembly index measuring the causal depth. So if you measure the construction history, but you think it's a physical property of any object in your environment, then basically what I'm saying is the thing that distinguishes me from a bacteria, or me from a molecule, or me from this microphone is actually how deep am I as an object in time, not just my physical dimensions as a spatial object. So, like you wouldn't know looking at me that like I'm part of a 4 billion year lineage. You might just think, like I'm 5'3", and you see the physical size, but you don't see the size in time. And so I think about all evolved objects as having actually a cause, like a causal history that is a physical property, and there is like this entire possibility space that's a physical space just as much as the three coordinates of space and are, or like the time, like coordinate time on clocks, which is actually more about simultaneity than it is about time in a progression of events kind of way, which is a whole separate conversation about relativity and things like that. But uh anyway, long
Well,
story
Well,
short,
no,
yeah.
this is great.
yeah.
Let's unpack that a little bit, because I'm just so I mean, obviously how complex something is, an organism, whatever, culture,
Hmm.
technology. Of course, time is a part of it. Are there other big things that kind of go into that? Is it just like the longer the universe exists, we're going to expect to see much more complex things, or is there something else that's driving that?
Well, it's a totally separate thing. So I actually, like, I have to be careful. Again, it goes back to the use of language. So I'm saying like time is a material property, and I do really mean that. But like the sense of time I'm talking about is a causal time, and not necessarily a clock time. So the sort of first base level that like is important to understand is that every theory of physics that we've ever developed has its own sense of time and its own way that time gets regularized into the theory, just in the same way like energy has different, like energy is kind of a universal, but it takes different manifestations in different kinds of physics. um but so like Newton introduced the idea of like a clock time, and like the universe basically moves through time, but time is not like a property of the universe. So like you have a state, and then at some time, and then like the universe has a next state at the next time. And then what Einstein's innovation was like actually to say that time is relative, and so this clock will measure a different time than this clock if they're moving at different reference frames. um like thermodynamics has another concept of time, which is the entropic arrow of time, which is to say that time has a directionality, and that directionality is moving in terms of increasing entropy. So there's kind of different concepts of time, and it's very unclear exactly how they mesh together for some of the theories, not all of the theories. Um, and what I'm talking about is causal time, which is to say that like the order of existence, that object, like things can come to exist, has a physical structure to it. That's what I mean by possibility space. It's like you can't be born before your grandfather, right? Like we're all familiar with that, but actually there's a hierarchy to existence, and an ordering to it. And so, like and so that hierarchy is actually what I'm talking about when I talk about causal time. And each object exists in that hierarchical structure. That tells you the depth is the assembly index. And so that tells you something about like the possibility space that actually had to be traversed to create that object, and how far into the structure of things that could exist that object is placed. And then that space, we call it the assembly space, is actually a physical space in the theory. And so just like my body can move, like in an XYZ coordinate space, physical objects can move in this assembly space in terms of like this object can be created because this object already exists, or this object is now impossible because I went down some other path. And so, so that's very abstract, and it's not like directly perceptible to our physical experience, except that we know what it is to have a creative act and to like actually create something that didn't exist before. And our mental architecture has a map of that space, just like it has a map of physical space. And I think it's just as physically real. And I think people have not appreciated this for most of human history, but people also didn't know that like space-time geometry was curved for most of history. So I don't think it's a huge leap in the history of science to propose that physical spaces exist and they have measurable properties. But where
Can,
we stand in science, because we think we know all of physics, people think it's a huge leap. um,
can I ask you
Thank
a
you for that.
question?
Yeah, I appreciate that.
Oh, I'm curious. So if we go all the way down to the perspective of like a single hydrogen molecule, where it's,
Mhm.
I guess, about as simple as can be, and you take one from the Big Bang, and you have whatever, I think 13 billion years or something since then, and it has a position that it's been in, like it's been in different
Mhm.
states, which is more of a geometry, like, but it's not become more complex in any way. Does it
It
sort of
doesn't
have
have any
time?
memory of any of that though.
Yeah,
So like
yeah, no memory of where it's
you
been.
you I mean, you couldn't recover that. You can say it had a history of different positions, but you can't recover that from the object, right? Like the hydrogen doesn't
Oh,
encode that. So
you
it's
would
not a
need
property
something
of
more
hydrogen.
complex to
Yeah,
actually
and
look at it.
Right. And that's why things like us get really interesting, and why I think we're not just emergent spatial patterns, which is the way that people would normally talk about life. Like one of the paradoxes is like of life is like life is an emergent property. It's not a part, it's not a feature of its parts. And people would use that to write off that life can't be fundamental because particles and molecules are like, you go to molecules and then you go to atoms and you go to elementary particles. That's fundamental because I've removed all the spatial complexity. But really what you've done is just remove all the memory and time. And what I'm saying is the memory and that causal structure is actually just as much a physical space. And that's the physical space that defines me, not just looking at where my atoms are in a spatial configuration, which is the way people would talk about it entropically. It actually is the configuration that's assembled over time that becomes the thing that we call life. And the fact that that entire structure is still, like I'm a compactified 4 billion year history in a 5-foot object. So it's like there's a lot of causal depth to have the universe make something like me. And so you and I are capable of talking about the history of that hydrogen atom because we have enough recorded history to actually even encode in our neural architecture that such a thing is a possible statement about the world. But the hydrogen has no knowledge of that. And so if I was an alien like you just can't recover that. And so it is worth talking about what information is actually intrinsic to an individual object versus what we project on the object, because we actually have that depth of information. And that's sort of the main distinction that I'm trying to make also with AI and other things, is that like we do not appreciate that as far as we know, we are the deepest structures the universe has created in terms of evolutionary causal time. And therefore, everything that we see in our environment is encoded in this very deep neural architecture we have in our brain and in our body. And it's wild that we can't see the universe outside that.
Okay, so what questions about like life or the universe do you think are genuinely unanswerable?
um, well, I think in some sense that the future will not be fully predictable ever. That's one. And I think that's very counter to the way that people think about things. Because I think people think if you have higher enough resolution and enough data, you'll be able to predict the future. And I think that the universe is intrinsically creative. And as you create more possibilities, the structure gets deeper. But there's also like the future horizon of what could be created is always bigger than the past horizon. And so the universe actually can't encode its own future. It doesn't have enough like computational capacity or memory to encode its own future. Um, so that's one. I think also with alien life, because I think the possibility space is so large, I think it would be very difficult for us to predict the exact instantiation of aliens until we actually encounter them. And so, there's a lot of conceptions that life on other planets is going to look like life on Earth, but I think this space is so large that when you start to evolve new structures out of chemistry, the potential space of what they could look like is so different that I don't have any anticipation of another planet following the same evolutionary trajectory that ours has. So I think a lot of the things that exist on this planet exist on this planet alone and will only ever exist here. And that's a really sort of also a radical reframing of the way that people think about things, because I think we just think we're common. And I mean, even in physics, we talk about like the fact there's a copy of you somewhere in the multiverse, and I just don't believe that. I think like you only exist here. Like this is it. But it's interesting actually, because historically, people thought the universe was really small, like both in size and in time. And so, I really like this historian, Thomas Moynihan's been writing about the history of how people think about like depth in space and depth in time and depth in possibility. And, makes this point about even a few hundred years ago, like I forgot who the person was, but like literally writing at their desk saying like, in several hundred years, I'll be sitting at the same desk writing this again, because they thought that the history of the universe was so temporally shallow, and like the spatial configurations would just repeat themselves on such a short time scale. Like the fact that humans have the recorded history we have now is the only reason that we can even conceive how big the universe actually is, because we're recording more and more history as we go, which means we're seeing a much a bigger and bigger glimpse of how big the universe actually could be in terms of the potentialities. And I think this is like one of the greatest shocks of human evolution, and also why LLMs are the latest existential trauma in that kind of space, because we're like, oh, well, that like human language is actually like this incredible, like deep structure. And I just like, and you couldn't even see what it looked like because it was just in our minds and in between us. And now you're seeing this whole extra dimensionality of how big a structure that actually is. Um, with large language models. So I think we have very limited perceptions. They're evolved on a planet over 4 billion years so that I can see what I can see, I can hear what I can hear. But the human mental architecture is recording that, and our societies are recording that, and and we're externalizing what's inside our mind, and also like seeing more of the world. So it's like that feedback process is um, really incredible.
So I'm gonna ask a question, and I think we both we're sticklers for certain words and how what they mean exactly. So you might not like the words that I use for this question,
It's all
but
right. I won't be offended. I
uh,
promise.
I just broadly want to ask the
Communicate
question.
without
So
words.
Yeah.
so some of these are not going to be correct. I know it, but with this causal time, I mean, I missed that
Hmm.
question, the word that you used earlier. So it's almost like maybe we can think of it as like tiers or sequences of events. So step 1, 2, 3, 4, 5, right? And maybe step
Hmm.
1 was bacteria, step 5 is humans, and then as we look back, we like just broadly speaking, and if we look back, we can kind of see this progression. It's more and more complex
Hmm.
over time. And of course, we're assuming by step 10, it's going to be that much more complex. And so I understand you're saying it's impossible to predict what step 10 is without playing it out in the real world and letting the
Hmm.
creativity engine sort of like build it in real time. We can't fast forward that progress. Um, but do you think over time it's possible that some laws will emerge that allow us to approximate, like, okay, by step 10, this is the technological and biological sort of complexity. This is kind of is there anything that we can kind of, look into the future?
I think we can predict the near horizon of where we are
Hmm.
when you're deep in the space of possibility, because you have to like each step, like in assembly theory, like when you take an assembly step, you're actually taking a step to construct a single object in a combinatorially explosive space. So like there's an exponentially growing number of possibilities.
Okay.
Um, and so when you take a step, you're taking a step into an exponential space and maybe realizing one thing out of that space. But it means that you can kind of predict the near future, but like the ability to predict actually, dramatically drops with how far in the sort of future of the kinds of objects that you want to predict is. So, and again, this goes back to a resource thing. Like maybe if you had more resources and you actually understood the causal mechanisms that construct the space, which is a challenging thing for us to develop theoretically. We worked it out really well for molecules and planetary atmospheres and minerals, but like trying to do this generally is quite hard. Um, as you're it depends on like if even if you know the mechanism, you don't have enough resource to predict, like like what the full space looks like in the future because it's too big. And so
Hmm.
so if I can predict the next step, then I have a combinatorially explosive possibility space after that step, and then after that step, and after that step. And so you're just going to run out of computational resource. Um, it's just in the way the universe handles that is it actually stores it in memory, and then it like if like once you have something selected, you kill off a whole bunch of things that are just never going to happen, because they become increasingly impossible. I like Stuart Kaufman has this concept of the adjacent possible, which is like like the possibility space that exists around like what's present in the biosphere, which I really love. But I also think in assembly theory about the adjacent impossible, that once you have a path that gets deep enough in this space, there are just some things that like there's no possibility for us to go back and like resurrect all of history. Although it's interesting, as you get deeper, you can start resurrecting objects like mammoths and things like that because you're deep enough to actually encode memory to like bring some stuff back, but you have to have some kind of recorded memory. Um,
Is it kind of like a light cone where like
mhm.
the higher the object is on the assembly index, the more possible states the light cone can kind of capture or predict?
Yeah, it actually, so light cones are a great analogy because they're basically built on causal limits. I think relativity is actually like causally a flat theory, which is like you only care about like photons and their causation, but you miss the rest of the structure of like the fact that existence is actually layered. And so I actually am doing a lot of work on like trying to think about relativistic assembly theory, which is really totally probably the most batshit thing I think about, but I really like it. But anyway, the point that I wanted to make is that is a good analogy because it's a causal space, and when you think about like this future horizon, basically you're saying I'm here. What could be causally constructed from where I am? And so it's like there is like any configuration that you observe in the universe has a possibility space that exists local to it that tells you what can be created from it and what was the past history of its creation. And that's actually what the assembly space encodes. But it doesn't mean that you could predict exactly what would happen. And the future horizon of the predictability, as I'm saying, drops off because the space just gets so large.
Is it limited in any way by stuff that could happen in evolution and stick around? Because we're probably not going to see some giant leap in abilities because it's usually like these kind of directional changes. We see some convergent evolution, like similar proteins in the eyes of like octopus and a human, like things like that, that seem to be like almost like there's not like there's certain like pathways that evolution takes that are more common. Does that change that in any way, shape, or form?
No,
No?
it's
Okay.
the same question you asked earlier about like, if you had the constraints, it would make, I forgot exactly the way you phrased it, but I had the same visual in my head. I was like, oh, here's the example. Like if you have the constraints, you're going to reproduce the same system. And so eyes are produced because, there are certain physical constraints in the architecture and a certain sort of template in the evolutionary history that like, that is the thing that gets generated because there's only a certain kind of like number of ways to make an eye,
Hmm.
like a
Hmm.
photon receptor. And so that's imprinted by like the environment of the structure the system evolves in. And the environment includes everything from the laws of physics to what
Oh,
other
I see.
organisms might be present, right?
Mhm.
So, the pathways can be limited, but they're what I mean is like, in the space of possibilities, these things have to be co-constructed so things can exist if the environment has the right memory and templating for that structure to be able to be created.
Yep,
Um,
that makes sense. Thank you. Yeah, so
yeah.
different environments, completely different
Yeah.
pathways, but
It's
yeah,
an interesting
gotcha.
feature of your cognitive architecture that you're like, like I always look for these kind of patterns when somebody asks the same question different ways. And I
Yes.
do this with my students. It's super funny because like I have, all these like brilliant PhD students I work with. And it's so interesting because they'll pick like what seem like diametrically different questions to work on scientifically. But it's really fascinating because like if you dig down into it, like they really just have like one core question they're trying to ask and they don't even like
Mm,
realize that they're actually just like
interesting.
fixated on this one thing.
Yeah,
Um,
yeah.
'Cause I
Yeah,
just have a bunch of polymaths I'm hanging out with over here.
I, I can't wait to just use that with Wes too. Like, oh, that's an interesting feature of your cognitive architecture. I
Yeah.
noticed. It's like,
He's
like,
gonna use it
oh,
as an
okay, thanks.
insult.
Yeah.
But that's
Interesting.
funny. I don't know, I'm always just curious
No,
about the way
yeah.
people's brains work because I think, it's interesting the way it goes back to what we were saying before. It's like people communicate things, but you actually have to, like, to build a model of what they're communicating. You have to understand, like, what are they actually so I'm just I cannot shut off my cognitive architecture's desire to find patterns, um, and then
It's
to build a
Yeah.
more unified abstract representation of those patterns. It's just the way that I work.
Yeah, it could definitely be a positive. That's an interesting
Yeah,
feature of your cognitive architecture. And,
yeah,
yeah.
totally.
maybe it's industrialism or entrepreneurship or pattern matching.
One really
I
interesting
don't
thing
know.
that I found recently is multiple people told me this, that they are finding that LLMs now are able to help them talk to people that have specific either personality disorders or some specific features that they're able to kind of like
Yeah.
translate almost like, oh, they said this is kind of what's happening. So it's, yeah,
Oh, that's
I,
so funny.
this is going to get more interesting to study, I think. So, yeah.
Well, I think think that also goes the other way, where I know a lot of people that are trying to use them to figure out how to communicate with like people
Right.
regularly.
Right.
Just like what would the average person respond to this? Like, how do
Yeah.
I communicate to people in the way that I actually intend to? So
Yeah.
Yeah, this
I think they're excellent devices for that, actually, because they're patterned on human language writ large. So, if I used to use social media for this, but now I'm finding I'm increasingly using LLMs, which maybe is not the best thing, but like, what would be the consensus representation in other people's minds of this idea I have? And so I used to do these, and I probably will go back to it at some point, but I was just very tired of social media right now. But like I purposely like write my like posts on X in a certain way, and then I would like read all the responses, because it like allows me to see, through this prism of social media, like, how does this one idea interact with other people's minds? And I'm very careful about how I linguistically represent it to try to see. And LLMs are a much flatter representation of that, but they're a much quicker way to get like a quick inference. So I don't think I get as much information out of them, but I think they can serve a similar utility.
Absolutely.
Yeah.
Have you
There-
had like an emotional experience with one, like where you kind of felt like it, like a poem or something written by an LM, like actually touched you and you had to
No,
remember, like, no, this is not another
no.
person?
No, because I don't construct meaning from words. I construct meaning from having a model of the mind that's communicating them, or a model of the social system. And for me, like, there is no underlying model that has any conception of what the words mean for an LLM. So like I use them as a proxy for human language, and like, what would the structure of human language be based on the way that like the model is trained for like this thing I'm interacting with. But I don't have any emotional model of an LLM. Like, it's just I just don't think there's anything there.
But
um
what does it seem like? So some of the people that are kind of thinking about long-term relationships with like avatars, or using that
well,
as
I
kind of
totally
a,
understand why. But as I said, because of the way that I've trained my own architecture on interacting with the world, because there's certain kinds of patterns I want to understand, I am not sensitive to the way that LLMs communicate. But other people that need emotional support and language in a certain way, or want some kind of feedback in in linguistic representation, and they actually find that to be the thing that's fulfilling for them, then it completely fills that need. But that's not actually the way that I interact with people, or the way that people communicate. And I have actually purposefully, um, I because I do science, and because of the science I work on, I'm much more hyper acute to that than most people are, because I have literally my entire adult professional career had to get my mind to look not at the way that people represent symbolic representations, but to try to look at the meaning behind them, to try to figure out like, what is the actual theory that would describe life. And maybe I'm particularly attuned to this anyway, but I've never been really sensitive to like the meanings of words. Even like, actually it came up kind of early in my career, because I was never really sensitive as a woman in science. Like, a lot of people would make this big deal, like, oh, you're a tough theoretical physicist woman in science, and I never thought of myself that way. And part of the reason is like I don't know if this is true, but like, there's some social cues that I think other people are sensitive to, that I just completely, like, they just completely miss me. Like, words people say like that are, because I just like, they're just irrelevant. I like, or they're just not like, they're not hitting my cognitive architecture in that emotional way. But I can totally see why it could be useful for people. But I think it's just like, people have to have caution with that, obviously, because just in the same sense, you have to have caution with a therapist, or you have to have caution with like an emotionally dependent partner. You have to be sure enough of yourself and your relationship to yourself to have a meaningful relationship with any other entity. And so I think the worry I have there is that it's just, like, if people are becoming codependent and they're not, like, the codependency is not actually building them to be dependent on themselves and actually have emotional support from themselves. That's bad, blanket bad, whether it's an LLM or another human being doing it. I think certain people have sensitivities to building those kind of relationships because they've had a hard history, and that's just tough.
so in your free time, you're not watching like rom-coms and The Bachelor and Love Island and stuff? And
Oh, I actually, some of them I do, sometimes, but
okay,
yeah, actually, I really have a hard time watching television these days. I don't know why. But I do like some things.
okay.
I like Emily in Paris because I like fashion a lot, but like it's a it's like so,
Yeah, yeah,
yeah. So there's like some things, but no, not The
yeah.
Bachelor. I mean, I'm a huge Mr. Beast fan. Um,
Mm.
Oh, that's cool. Yeah. 10 people
But
on an
mostly
island.
because I think he's so intellectually, like, he's such a fucking genius. Like, so I watch them not because of the clickbait value that they have, but because I'm trying to think about like him as a creative person that generated this,
Hmm.
that's engaging so many people. So it usually for me to find enjoyment and entertainment, I have to think about it across multiple levels, and I always just want to know the mind behind the thing.
Yeah. You could
Um,
probably get a hold. Have you met him? I feel like you
no, I
might know the
haven't
kind
met
of
him.
people to
Yeah, I haven't
connect
met
with
him,
him.
but yeah.
All right.
Probably at some point. I hope so, but yeah, I think he's just super cool.
Yeah,
Yeah.
it's such a fascinating conversation. I wish we had so
Yeah.
much more because there's so much overlap that I think we have, not just with the science, but just like the personal stuff that you're talking about, not or whatever, like how you perceive other people, how you perceive words. That's so fascinating because a lot of these things that you're saying is like really resonating with me because I have kind of these analogous things that
Yeah.
I notice. So I just thought that was absolutely brilliant. We want to be respectful of your time. Do you have a hard out right now? Should we wrap it up? How do you feel?
Okay for a little bit longer. So if you feel like there's something you want to do to wrap it up, that sounds good. I don't have
Phen-
to dash off, but
Thank
not
you so
keep
much. I
you from
appreciate that. Yeah, this is absolutely phenomenal. So, Dylan, do you have anything that we should? Mhm.
Yeah, well, I guess I was gonna kind of look at because good science has ways to like disprove things. Like,
Yeah.
if assembly theory turns out to be wrong, like in some
Right.
kind of fundamental way, like in what ways might it be wrong or disproved or lead to sort of
Sure.
a
So,
pivot?
I already mentioned Popper, but I'm a huge fan of the falsifiability criteria for scientific theories. Like, I don't think you can prove a theory right, but you can certainly prove a theory wrong. And actually, I personally don't think that any theory is a permanent solution to understanding reality. So I fully expect assembly theory would be replaced by something else if it becomes a framework that, like actually stands up to the scrutiny that it's under now and becomes a framework that we use for understanding life and intelligence in the universe. It will be replaced by something else. Um, so I just want to give that caveat because people have this kind of conception of a theory of everything, like we're going to get some grand unified final description of nature, and I just think that's a artifact of 20th century thinking and not really a realistic way of thinking about the structure of theories or what they do as a human cultural system. Um, so that being said, assembly theory has a lot of empirical tests. The ones I'm most interested in are the robustness of this idea of a threshold in assembly index and copy number, like how many of a repeated high assembly object you have, um, as a threshold that divides the non-living and living universe in some sense. And so Lee's lab did this really fabulous set of experiments in a paper published in Nature Comms a few years ago, where they took a whole bunch of living and non-living samples, and they did this mass spec experiment measuring the molecular assembly index of molecules in these samples and showed that there was a threshold of 15, above which you only found molecules that were produced by a living system. So there were no abiotic, non-biological things could make molecules of assembly index 15 or higher. And I think so that threshold is actually system size dependent. So Lee and I just wrote this philosophy paper recently and derived cosmological bounds. Like if the universe had no life in it, what would be the highest assembly index molecule you could possibly find? And it's probably between 40 and 60. It kind of depends on how you parameterize your model, but like probably about 58 or so. But like you could actually develop theory to precisely pin down this number. And like basically anything above that, which is, any DNA molecule or any protein is above that, is something that the universe, like if you find it in the universe, is a surefire sign of life because using the entire resources of the universe with no selection and no evolution, you would never produce something of that assembly. So basically, you have a range of 15 to say 60, um, that you can actually make predictions, and I think we could predict, like for meteorites, what would be the highest complexity you would expect. For minerals, what would be it? We have some stuff that we're doing for planetary atmospheres now, where we've applied assembly theory to planetary atmospheres, and it's actually like really compelling because you don't have to put any knowledge of any planets in. And if you take all of the known planets with atmospheres and their properties, and you put this in an assembly theory framework, you can see that Earth's modern biosphere is the only one that has high assembly and high potential possibility space. So I guess what I want to see is more ways of testing this conjecture of this threshold and how robust it is in different physical systems. So in a molecule, an individual molecule can be the signature of evolution. An entire planetary atmosphere can be the signature of evolution with this theory. A mineral could be a signature of technology because it's precisely designed, like a silicon chip. Like if I looked at a silicon chip uh,
Yeah.
versus like a rock, how do I know the difference? Assembly theory can tell you why a silicon chip is a deeper constructed object than the rock. If I look at a large language model. So I think what we're trying to do right now is basically say we have a theory of physics developed in molecules that tells us that there is a firm experimentally testable threshold above which we have definitive evidence of life. And I want to test it in as many systems as possible. I could have said that as the short version before I went into all the detail, but there you have it. That was the short
No,
version I got
that's yeah,
there.
that's
No, this
good.
is great. Yeah. So I mean,
Yeah.
good.
You sure? Okay, I feel like I've definitely monopolized the
No,
questions,
no,
but
no.
I guess okay. What? No, you go. I'll make sure you go next. But I guess I'm saying this theory is like pretty ambitious, and if
Yes.
it does kind of hold up the test of time, maybe for the next decade or so, and you feel like enough of these tests have kind of been done, and it still is like resilient. Do you feel like you might be in for a Nobel Prize?
Well, that's such a funny question. I would be more excited if I could raise enough money to do the experiments to make life in the lab. So if I can do that in 10 years, I'll be happy. A Nobel Prize is a nice thing to get, but I don't it's sort of
Yeah,
it's an after the fact thing. And also the other thing about the Nobel Prize that's kind of hard is like most people when they get the Nobel Prize, like their career is kind of killed in some sense because they get asked to do all these like public engagement events and things like that. And you'll see like most Nobel Prize winners, like a few of them do really great work after the Nobel Prize, but a lot of them end up not doing, like and I don't know. I think the work that Lee and I are doing, always our goal is to have it be of that caliber. But I think, for neither of us is that the goal. And if that was the goal, we wouldn't be really doing
sure.
science.
Yeah, and
And
that's
so I think it's really clear to make that distinction because so many people in science are actually like there is a career path in science, right? Where you check all the right boxes, you can get in the national academies and you can get a Nobel Prize and the stuff. And if you have the right peer network and you're working on the right ideas. And I think both of us are just so fundamentally interested in how the world works that there is no other question. And so yeah, so I'm very flattered that you would ask that, but like I just want to really make clear about what is it about? Because like what we're doing is hard and it's under a ton of scrutiny, and
well, and
it's very critical.
and I know it's like a very tough question to ask somebody like how great are you? Like are you that great? Like tell me
Well, right
exactly.
now it
But
doesn't feel so great. Like I mean,
yeah,
it's the flip side of it is when you propose new ideas in science. Science is like any other part of human culture. People have, they have confirmation bias and like certain sets of beliefs. And if you challenge them, the community has a reaction to that. And so, like that one of the things that's really hard right now is assembly theory is very different as a conceptual framework and also as a theoretical and empirical science than what we have in the standard literature. And so there are a lot of people that want to write it off immediately as wrong and not even give us the chance to like actually like they won't read the science or they like they they'll adopt someone else's critical opinion um just on hearsay, right? So there's a lot of ad hominem and like attacks on assembly theory as being like obviously wrong. Like this is the statement people make, it's obviously wrong. And they don't even look at the empirical data or what the structure of the theory is. It just has to be wrong because it doesn't conform to my beliefs about how the world works.
yeah. My
And that's not
in
science.
my gut instinct is that like if thinking about something as an assembly index turns out to be how somebody wants to confirm detection of any kind of
Yeah.
extraterrestrial like biosignature or something, then all of a sudden it seems like it would be kind of in reach.
Yeah.
Yeah.
I
But
mean,
Yeah.
I'm hoping that we'll have observational research programs for exoplanets soon based on the atmospheric assembly stuff, but we still have to get like the first paper out on that. So, like we're not even at the observing point. We just have done the theoretical work, and I think it's incredibly promising. But I think that's one of the reasons that my answer to you was like actually one of the things we're doing is critically testing this theory in as many ways as we can. And um I don't like this idea that I work on assembly theory and I have some like soapbox I'm standing on. Like the thing that I have done my entire career is I want to understand what life is. And I started, as a postdoc and even as a grad student, wanting to build a theoretical physics that would help us solve the origin of life. Like that is my career goal. And assembly theory has emerged for me out of that desire and the fact that like that is my only career goal. And Lee was the only person that I think was as crazy as me to care more about the problem than anything else, like anything that we were taught or thought before. So assembly theory is for me the current incarnation of that is like it is basically building in every idea I've ever had about like what I thought and like all of these colleagues. We have an amazing set of colleagues working on it. And there is a lot of really rigorous intellectual work behind it. But if it's proven wrong, we're going to move on to the next thing. And so I'm investing a lot of time in right now because I think it's so promising and I really want it to undergo the scrutiny that I think a promising theory deserves. But, it's going to take us time to develop, like, we have to develop all these new mathematical formalisms, all this theoretical infrastructure, all these empirical tests, which require new ways of, like, actually accessing and interrogating experimental data. I mean, it's just like, it's so many moving parts. That is, I hope in 10 years that we can prove the things that we say, but research is slower than the ideas you have. So it's always a long haul. Yeah.
Yeah. It's such an interesting, and it seems like it's really developing. It's, as far as I know, it's a little bit more recent. One of the things that I heard recently, so there was an interview with Blaise Aguirre y Arcas, who's working over
Mhm.
there at Google. Are you aware of him?
Yep. I've met him. Yeah.
Oh, yeah. Oh, absolutely.
Yeah.
That was an eye opener for me, the BFF experiment. I was like,
Sure.
wait, you know what I mean? And it seems to really tie into what you're talking about. And just, yeah,
Yeah, those kind of things. I have a colleague, Michael Lockman, that wrote some code. Like, I mean, like 20 years ago. So like they couldn't do it at the scale that Blaze and his team did now. But Michael had this really great thing that like had emergent self-replicating programs in it. So I think like we've known about those kind of things for a while. And I really like Blaze's experiments. I think they're super cool. But the issue I have is like there's already so much historical evolutionary information in the algorithm that I don't really see it as a I see it as a good window into the origin of life, because really what we're talking about is like you go from no information to a lineage that emerges and has memory and the causal ability to construct itself. And I don't think I think algorithms are already very deep evolutionary objects because they were created by humans and they're embedded in computer architectures that already have to be designed. That I think it's really hard for me to think about the origin of life in a simulation like that.
yeah. And just one final question.
Yeah,
Sorry.
sorry. No, just one point on that, though. I think the origin of life is a continuous process also, so it can happen in new substrates. So I do think, like, what Blaze is doing is giving us some insight, right? But it's like you just have to understand the evolutionary scaffold, and then you open up a new space and you see the origin of life happen again in that new space. So I just want to give that caveat, but yeah. Um,
And so, just when we're thinking about this, like complexity, how would you rate like the human brain versus, let's say, a super intelligence? Like, does one have a higher, lower assembly index? I mean, that seems pretty obvious, but you would like, does that make
I
that's
don't even know what a super intelligence is. People throw this
right?
word around. I literally don't know. It has like no definition for me. What is it?
Hmm.
More intelligent than a human on what scale? Um, so I would rather just try to ask first principles questions about what intelligence is before I want to conjecture about some supreme intelligence that surpasses humans. And already, I like David Deutsch's perspective on AGI, which is by virtue of the fact that we invented the theory of universal computation, like we're already like humans can do any computational operation because we have a model of universal computation. So anything that any of these super intelligences can do, we can do. It's just a matter of the time scale to do it. So LLMs are really good at some reasoning tasks and can do them super fast, and we're good at some and can do it way faster than an LLM. And so it just depends about the accessibility of the information. So anytime that you take this abstract idea of intelligence, superintelligence, universal computation, and you embed it in an actual physical system, it's going to have some limitations on it. And the idea of superintelligence and AGIs that are discussed about now act as if the physical universe doesn't exist and there's like no upper limit on intelligence on any given physical system. And I just don't think that's a realistic possibility.
Yeah. Phenomenal. Thank you so much. You've been absolutely great.
Yeah.
And if you can explain stuff to us in a way that we can understand it, I'm sure everybody else will understand it. That's the one thing we can guarantee here. But
so funny.
Yeah.
Thank you.
That's good. I hope I understand it. I'm not like
No.
I'm not sure if I understand anything I say.
For whatever
Oh,
it's
yeah.
worth, somehow a lot of the stuff feels intuitively right. I don't know if that makes sense, but a lot of the stuff.
Yeah, no, yeah, sure. I know exactly what you mean, because most of like the way that I think about things is based on intuition. So
Yeah.
Yeah.
I
It's
think
nice.
intuition is underrated. Yeah, sorry, Dylan. I didn't mean to
No,
cut
that's
you
it. Yeah, intuition. Yeah, it kind of gives, like, when I listen to you too, I get sort of this sense like of a North Star, even though I
Yeah.
can never repeat anything I've heard from your podcast. I'm like, okay, I think I learned something and the world feels different.
Yeah, it's actually very a lot of my perception on language comes from like obviously talking to other people and understanding how they interact with the way I think. But the thing that's kind of funny there is I think I explained to you guys about how I try to read the meaning below the words that people use, and I think that's also how I try to communicate. Although I really don't know what that looks like in somebody else's mind, but it's like like for me it's very like there's a certain representation I have in my mind, a very emotional intuition thing. And then like, it's not very easily to encode in human language. So I just basically try to communicate that directly, but I have to use words to do it. And I don't even know how I build those layers in there.
Yeah.
Yeah,
I
that's
struggle
good.
with that as well quite a bit. And I feel like
Yeah.
a lot of people don't even think about that. So it's kind of like this almost like speaking a different language when I try to, what do you mean
Yeah,
by that
totally.
word? Yeah.
Yeah. And then there's also all kinds of things that like I think written language is a fundamentally different language than spoken language. But we think they're
Interesting.
the same because we use the sort of same words and same symbolic representation. But I don't know about you guys, like I get a text from somebody and it's like they all read angry to me. Like if I'm like, but if I talk
Oh,
to the person, it's
yeah.
like very clear they're not angry. So it's kind of like like I like text messages are really hard for me because I don't have the emotional like input of like the modulation of the voice. So I have a really hard time reading text messages and
Yeah,
getting
same.
meaning out of them. But
No, I definitely, yeah, text and emails, I feel like they've slowed down the world
I
somehow.
know,
They're like
I
tough for me
know.
too.
Yeah.
But it's good. And you made me a presentist. I think I'm now like seeing everything that I think is coming up in the future is just some pattern from the past I'm projecting. So
Yeah,
it's very good.
totally. But there is real novelty too, so that's also exciting.
Thank you
It's
so much
fun.
for sticking with us so long. And we'll see you in the next episode. Thank you.